I'm going to go through the test review and kind of go through the answers. I'll give you some hints and stuff like that. So number 1, I'm talking about a license plate consisting of letters and digits. So for letter A, it says how many possible license plates are there if letters and digits may repeat. Okay. Now, you're going to say, so remember, when you have 4 letters, okay, so we're going to make 4 spaces. So 1, 2, 3, 4 for letters and 2 for digits. Now, we are allowed to have repetition. So when we talk about letters, we're going to do 26 times 26 times 26 times 26. Now, there are 10 digits. 0 counts as a digit, so 0 through 9 are going to be 10 digits and 10 digits, okay? So how many possible license plates we can have? Well, we're going to multiply them together. And we should get 45,697,600. Okay? Letter B. So we still have our 4 letters. We have our 2 digits. Now the only difference is that it says we cannot repeat. So as soon as you pick one of the 26 letters, you're going to have 25 left for the second, 24, and then 23 left for the last 2. And then when you pick your letters, you'll have 10, and then you'll have 9. So when you multiply those, you should get 32,292,000. Okay? All right, now you are going to tell me for the next couple or several questions, okay, whether they are permutation or combination, and then you're going to do your answer, okay? So for number 2, a counselor has 8 open slots in her schedule. She receives requests from 5 students, and how many ways can she reschedule her students? Now, this is going to be permutation because order matters here. It matters, okay, because students have specific names and we can't just see random people, okay? So it's going to be permutation. It is going to be 8 permutation 5, and you should get 6,720 as your answer. Okay? Number 3, in how many ways can a team of 14 field hockey players choose a captain and co-captain? Now, the key word here is captain and co-captain. They have 2 different roles for 14 people. So 14 permutation 2. When you do it in the calculator, you should get 182. Okay, number 4, in how many ways can a student body of 155 students select 3 representatives? Now, this one is going to be combination because I did not say whether the representatives have different roles, okay? It's just anybody to represent in that student body, okay? So we're going to say 155, choose 3. You should get 608,685. Number 5, Mary has homework for 4 subjects, and how many ways can she do 3 of them? Now, this is going to be combination, okay? I didn't say what I didn't say anything about what type of subject, okay? So she has 4 subjects, and how many ways can she do 3 of them? Excuse me. Okay, so you should get 4 ways. All right, number 6, in how many ways can 5 people arrange themselves in an SUV that sits 6? Okay, this one is going to be permutation. Okay, there are 6 total people you're choosing from and 5. Okay, order matters here because you can't sit one person and sit the same person somewhere else. Okay. This one's going to be 720. Number 7, Jose has homework assignments in 5 subjects. He only has to do 3 of them. This one is going to be combination. So he has 5 subjects, only has to do 3 of them. Okay. All right. Let's see. So 5 choose 3. This is 10. Number 8, the batting order for 7 players on an 8-person team. Now, keyword here is batting order. This is permutation. So 8 players on a team and you're choosing 7. So 40,320. Selecting 9 players will be in a batting order on an 11-person team. So you're just selecting the people who are going to be in that batting order. You're not actually choosing the batting order. So this one's going to be combination. And you have 11 people and you're choosing 9. So it doesn't matter. This one you're just choosing the players who are going to be in the batting order. You're not actually choosing the batting order. And you're going to get 55. Okay, number 10. How many different ways are there to purchase 2 CDs, 3 DVDs, and 1 set of headphones if there are 7 CD titles, 10 DVDs, and 3 types of headphones available? All right, so you have, now we need to sort this out between CDs, DVDs, and headphones, okay? So out of a total of 7 CDs, we are choosing 2. Then we have a total of 5 DVDs and we're choosing 3. We have a total of 3 headphones and we are choosing 1. Okay, so if we take each combination and multiply, we should get 630. All right. Number 11, how many ways can you choose 3 shirts, 4 pants, and 2 shoes from a closet that has 7 shirts, 4 shoes, and 10 pants, okay? So 7 shirts, and you're choosing 3. 10 pants, and you're choosing 4. And 4 total shoes, and you're choosing 2. When you multiply those together, you are going to get 44,100. Okay, next page, compound probability. You're going to state if the scenario involves mutually exclusive, overlapping, independent, or dependent events, and then you're going to find the probability. So for number 12, you roll a fair 6-sided die. What is the probability that you roll an even number or a number less than 6? So key word here is or, okay? Or means it's either going to be overlapping or mutually exclusive. Okay, because you can get an even number and a number that is less than 6, okay, they both overlap, your answer is going to be overlapping. Okay, so this is overlapping. Now, to find the probability, you're going to take the chances of you rolling an even number, which is 3 out of 6, and you're going to add it to the chances of you picking a number less than 6, which are 5 out of 6. You're going to subtract the overlap, so numbers that are less than 6 and even are the numbers 2 and 3, so there's 2 of them. So you're going to subtract 2 out of 6. That gives you 6 over 6, which is 1, and it is okay to have 1. Number 13, there are 5 nickels, 3 dimes, and 5 quarters in your pocket. You randomly pick a coin. What is the probability that that is a nickel or a dime? Okay, so keyword here is or, so you know it's going to be mutually exclusive or overlapping. Now, looking at your 2 events that you have, it says a nickel or a dime. Okay, those are 2 totally different things. There's no overlapping, so this one's going to be mutually exclusive. Okay, So you're going to take the probability that you get a nickel, which is 5 over 13, and you're going to add it to the probability of getting a dime, which is 3 over 13. So you have 8 over 13 is your answer. Okay. 14. A cooler contains 13 sports drinks, 6 lemon lime and 7 orange. 2 of the lemon lime and 5 of the orange are cold. What is the probability that you grab a drink that is orange flavored or warm? So keyword here is or. So you know it's going to be either mutually exclusive or overlapping. Now, you can have an orange drink that is warm or cold. So there's going to be some overlapping here. So I'm going to say overlapping. Okay. Now, you have to find the probability that you're going to get an orange drink. Okay, so the probability of getting an orange drink is 7 over 13. You're going to add that to getting a warm drink, which is 5 over 13, and you're going to subtract the 2 orange warm. So 7 plus 5 is 12. 12 minus 2 is, oops, sorry. Yeah, it should be 10 over 13. All right, number 15. A bag contains 3 red marbles. 5 marbles are blue, 5 are yellow. We randomly pick a marble. The marble is red or blue. Okay, keyword here is or. Or is mutually exclusive or overlapping. This one is going to be mutually exclusive because you cannot have a red and a blue marble come out. All right. So the probability that you pick a red marble is 3 out of 13. Probability that you pick a blue is 5 out of 13. And your probability is 8 over 13. Okay. 16. A basket contains 6 apples and 6 peaches. You randomly select one piece of each fruit and eat it. Then you randomly select another piece of fruit. The first piece of fruit is an apple and the second piece is a peach. Okay, so you have to find that probability. So my keyword here is and, so you know it's going to be independent or dependent. Okay, now another keyword here is that I ate it. That means this is going to be dependent. Okay. All right, so your first probability is that you get an apple. Okay, so the probability of you getting an apple is 6 over 12. You're going to multiply that by, now there's 11 fruits for you to choose from because you ate one. And then your peaches is 6. So you have 36 over 121. Oops. Yeah, not 121, 132. That simplifies to 3 over 11. Okay, number 17. A spinner has an equal chance of landing on each of its 8 numbered regions. You spin twice. What is the probability that the first spin lands on a region 1 and the second spin lands in region 2? Okay, so these are going to be independent because I said I want it to land in 2 different regions. Okay, so this is going to be independent. Okay. The probability of you landing in region 1 is 1 out of 8. The probability of you landing in region 2 is 1 out of 8. So you have 1 over 64 is your probability. Okay, number 18. A box of chocolate contains 4 milk chocolates and 4 dark chocolates. You randomly pick a color or a chocolate and eat it. Then you randomly pick another piece. What is the probability that both pieces are milk chocolate? So this one's a little bit worded differently because I'm saying that both pieces are milk chocolate. I'm not saying that they're 2 different ones. So I'm going to assume that this is an and statement. So independent or dependent. Another keyword here is I ate it. Okay, this is going to be dependent. because I ate it. So my second choice depends on what I did my first choice, okay? So the probability that you have a milk chocolate is 4 out of 8. I'm going to multiply that by, now I have one less chocolate. I'm assuming I ate a milk chocolate already, so there's 3 that are left, okay? So 12 over 56 simplifies to 3 over 14. Now, the reason in number 16 that I did not simplify my numerator up here was because I'm choosing a different fruit. So at first I chose an apple and then I chose a peach. If I would have said that they're both apples, then I would have had 5 over 11 for my second fraction, okay? Okay, number 19. A bag contains 3 red marbles and 4 blue marbles. You randomly pick a marble and then return it to the bag before picking another. What is the probability that the first marble is red and the second marble is blue? So keyword here is and. And means independent or dependent. Because I cannot pick a red and a blue at the same time, I'm going to assume that they are independent. All right, my probability of getting a red marble is 3 out of 7. I'm going to multiply that by getting a blue marble, which is 4 out of 7. Okay, another keyword here tells me it's independent is that I return it. All right, part 3, conditional probability. Andrea is a very good student. The probability that she studies and passes her mathematics test is 17 out of 20. If the probability that Andrea studies is 15 out of 16, find the probability that Andrea passes her math given that she studied. Keyword here is given. Now, all of these problems are going to have given in them. Therefore, they are the conditional ones. That means you have to use that formula, okay? Now, that formula, remember, is the probability of A and B over probability of B, okay? So your numerator for number 20 is 17 over 20. Now 17 over 20 as a decimal is 0.85. I'm going to divide that by 15 divided by 16, which is 0.9375. So 0.85 divided by 0.9375. And that gives you 0.91. Now, that's your probability. So you're going to leave it as 0.91. Okay? So I can erase that. So 0.91 is your probability. Okay? Number 21, the probability that Janice smokes is 3 out of 10. With the probability that she smokes and develops lung cancer is 4 out of 15. Find the probability that Janice develops lung cancer given that she smokes. So remember, my and statement probability is going to go on the top. Okay? So my and statement is that she smokes and gets lung cancer, which is 4 divided by 15. So that is about 27% chance. You can round. That's okay as long as it's 2 decimal places. And then the probability that she smokes is 3 out of 10. So 0.3. So 0.27 divided by 0.3 is 0.9. So that is your probability. You could also say 0.90. That is okay too. Okay? Now, if your answers are a little bit off than mine, if they're like, 0.88 or something like that, or 0.89, it's just because I rounded in my numerator, but it shouldn't throw off your answer too much, okay? Number 22, the probability that Sue will go to Mexico in the winter and to France in the summer is 0.40. So there's my and statement, so I'm going to say 0.40 in my numerator. The probability that she will go to Mexico in the winter is 0.60, so that is just one single event. So 0.40 divided by 0.60 is 0.66667. So we can round that to about 0.67 as your probability. All right, 23. A penny and a nickel are tossed. Find the probability that the penny shows heads given that the nickel shows heads. Okay, so probability of A and B. So the probability that I have a penny and a nickel, okay, it shows heads because there's only two sides, okay? So this is 1/4. So I'm going to have 1/4 divided by probability of just getting a head, okay, is on the nickel, okay, is 1/2. So I have 0.25 divided by 0.5 is 1/2. So that's my probability. Okay. All right, a penny is tossed. Find the probability that it shows heads. Compare this answer to your answer number 23. Okay, now I'm just saying I tossed a penny and I need to find the probability that it's heads. That's just one event. So that is 1/2. Okay, because I have two sides. I have tails and I have heads. And I want heads. Okay, so that is my probability.